Hello students, we move on to the final part of the surface areas and volumes. A quick recapitulation of the formulas of various solids: cuboid, cube, cylinder, circular cone, sphere and hemisphere. In today's session, we would understand how conversion of solid from one shape to another affects the various mathematical forms. Let's take the first example. A cone of height 24 centimeter and radius of base 6 centimeter is made up of modeling clay. A child reshapes it in the form of a sphere. Find the radius of the sphere. So you can see this is the cone. This has got 24 centimeter as its height and the radius is 6 centimeter. This is of clay, so which has taken the shape of a sphere. You need to find the radius of this sphere. Let's proceed towards the solution. You know the volume of the cone is 1 by 3 pi r square h. So using this formula, 1 by 3 into pi into 6 into 6 into 24, you get the volume of the cone. Now if r is the radius of the sphere, then its volume will be 4 by 3 pi r cube. Now since the volume of clay in the form of the cone and the sphere remains the same, because it is the same clay which is being used to make the cone and the sphere. Hence the volume of the cone and the sphere will be same. So we use that logic. 4 by 3 pi r cube will be equal to 1 by 3 pi r square h. Substituting all the values, we will be able to find out what is r cube, which is equal to 3 cube into 2 cube. Whenever you want to find out r radius basically and r cube you know, so first convert the number into factors and try to make groups of 3. Like you can see over here, it is very easy. Once you do it, 3 cube into 2 cube, you know that r is equal to 3 into 2, 6. Hence the radius is equal to 6 centimeter. A second example. A hemispherical tank full of water is emptied by a pipe at the rate of 4 by 7 liters per second. How much time will it take to empty half the tank if it is 3 meter in diameter? So you can see in the picture over here, this is a hemispherical tank. This is a hemispherical tank over here. It's full of water. It is emptied by a pipe. So this is the pipe which is used to empty it at the rate of 4 by 7 liters per second. So the pipe is in the shape of a cylinder and the diameter of it is given 3 meter. The question is, how much time will it take to empty half the tank? So let us understand how to solve. Now the radius of the hemispherical tank is 3 by 2 meter. So you can take out the volume of the tank. So once you know the volume of the tank, which is 99 by 14 meter cube, please remember that the water to be emptied is given in liters. So you need to convert the unit meter cube to liters. 1 meter cube is equal to 1000 liters. So whatever answer you get, 1 by 2 into 99 by 14, which is 99 by 28, multiply by 1000. So you're getting 99,000 by 28 liters. So now you can use either the unitary method or the time and distance method, whichever you find it easy. Unitary method is much simply used. So wherein you can say that 25 by 7 liters of water is emptied in 1 second. So 99,000 by 28 liters of water will be emptied in 99,000 by 28 into 7 by 25 seconds, which is equal to 16.5 minutes. This is the next example. A metallic spheres of radii 6 centimeters, 8 centimeter and 10 centimeter respectively are melted to form a single solid sphere. Find the radius of the resulting sphere. So these are three metallic spheres. You can see 1, 2 and 3 are metallic spheres. All the three are melted and you form a big sphere. You need to find out the radius of this big sphere. So it's very simple. You need to take out the volume of all the three, add the volume, which will be the volume of this big sphere, and then from this volume you need to take out the radius. Just look at the calculation. Volume of each sphere you take out, and then the resulting sphere, suppose it has got r as the radius, so it will be addition of all the three volumes. So once you add all, you will be able to get the radius of the resulting sphere. So once again over here, r cube is equal to 1728. You need to take out the prime factors of this number so that you can club it into groups of 3. So 12 centimeter is the radius of the sphere. Moving on to the next example. A well of diameter 3 meter is dug 14 meter deep. The earth taken out of it has been spread evenly all around it in the shape of a circular ring of width 4 meter to form an embankment. Find the height of the embankment. So as you can see in the picture over here, this is the well, and well is cylindrical in shape, and this is what is the embankment which is formed all around. So you need to find the height of the embankment. So in mathematical shape, this is how it appears. The well is dug below. So this is the cylindrical part which is the well, and this is the embankment. So radius, the depth of the well is given 14 meter. The diameter of the circular end of the well is given 3 meters. So the radius is going to be 3 by 2. And width of this is already given is 4 meter. Okay. So as you can see from the figure, the embankment is also a cylinder which is having an outer radius. You can term it as R2, which will be 4 plus the inner radius, which is 3 by 2. So the outer radius is 4 plus 3 by 2, which is 11 by 2 meter, and the inner radius is 3 by 2. The height of the embankment will be the volume of the soil dug from the well, because whatever is the soil dug from the well is being used to make the embankment. So this volume of the cylinder, which is the well, so volume of the soil dug from the well is equal to the volume of the earth used to form embankment. Remember, this is a very, very important line in this question which you must write. So volume of earth used to form embankment. So this particular concentric circles that you can see, which is a cylinder which has got 2 radii. So you need to take out the volume of this and this volume will be equal to the volume of the soil dug from the well. So solving this, you will be getting this particular volume. Substitute all the values, you will get the height of the embankment. The next example, a container shaped like a right circular cylinder having diameter 12 centimeter and height 15 centimeter is full of ice cream. The ice cream is to be filled into cones of height 12 centimeter and diameter 6 centimeter having a hemispherical shape on the top. Find the number of such cones which can be filled with ice cream. Now you can see over here, this is a right circular cylinder. This is a right circular cylinder over here. The diameter is given 12 centimeter and the height is given 15 centimeter. This is full of ice cream. Now this ice cream is to be filled into cones. Now the height of the cone is given 12 centimeter and the diameter is 6 centimeter. So you need to find out the number of cones that it will fill. So the logic is very simple, that the number of cones will be volume of cylinder divided by the volume of ice cream cone. So you need to take out the volume of cylinder. All the measurements are given. So use the formula pi r square h. So you will get the volume of the cylinder. So similarly, you take out the volume of ice cone part. Radius is given, height is given. So you take out the volume of the ice cream cone. So once you get the volume of the ice cream cone, which is the cone plus the hemisphere, put the values. You get 36 pi plus 18 pi. So number of cones will be volume of cylinder by volume of the ice cream cone, which is equal to 10. Next example, how many silver coins 1.75 centimeter in diameter and of thickness 2 millimeter must be melted to form a cuboid of dimension 5.5 centimeter into 10 centimeter into 3.5 centimeter. So you have the silver coins. The diameter of these coins are given and thickness is also given. Please remember the unit. One is in centimeter, the other one is in millimeter. So the first step will be to convert all the units into same unit. So the coins which are cylindrical in shape, height is given 2 millimeter, which becomes 0.2 centimeter. The radius is given 1.75 by 2, which is 0.875 centimeter. So the number of coins to be melted to form the required cuboids be n, because we do not know how many coins. So let the volume of n coins excuse me, volume of n coins equal to volume of cuboid. So you take out the volume of the cuboid, which is already given, length, breadth and height, and volume of one coin is given. So you divide both, you're going to get the number of coins, which is 400. Next question, a cylindrical bucket 32 centimeter high and with radius of base 18 centimeter is filled with sand. This bucket is emptied on the ground and a conical heap of sand is formed. If the height of the conical heap is 24 centimeter, find the radius and slant height of the heap. A very interesting question. A bucket is full of sand. This sand is emptied in the floor and you are making a conical heap of this sand. So which is a cone basically. Now you know the volume of the sand in the bucket because 32 is the height and the radius is 18, which is given. Since both the measurements are given, you can take out the volume of the sand. Once you know that volume of the sand, now you are making a cone which has a height 24 centimeter. So 24 centimeter is the height is also given. Now you need to use the formula of volume of the cone to take out the radius. Okay, let us proceed. So this is how the diagram, mathematical diagram appears like. So you have the height of the cylinder given, the diameter given, so you know the radius, and plus the cone, you know only the height is 24 centimeter. So this is what is given. So you know that the volume of the sand in cylindrical bucket will be equal to the volume of the sand in the conical heap. So using the formula, we will be getting the radius, which is 36 centimeter, and slant height will be, using the Pythagoras theorem, you get the slant height. Okay, this is a question on the canal. Water in a canal 6 meter wide and 1.5 meter deep is flowing with a speed of 10 kilometer per hour. How much area will it irrigate in 30 minutes if 8 centimeter of standing water is needed? So this is the picture of the actual canal, and you can see the mathematical representation of the canal wherein the height is given 1.5 meter and the width is 6 meter and the water is flowing at a speed of 10 kilometer per hour. So this is, first you understand, this is the figure of the canal. Now it is in 30 minutes it is going to irrigate a particular area wherein 8 centimeter will be the height, basically standing water, right? So let us understand how to solve this. Now first and foremost, the canal is in the shape of a cuboid. Since it is in the shape of a cuboid and you have a height and base mentioned over here, the speed of the canal, which is given 10 kilometer per hour. Once again, please look at the units. This is kilometer per hour. So we need to convert it into meters. So first step will be to convert all the units into same units. So length of canal covered in 1 hour is 10 kilometer because the speed is given 10 kilometer per hour. So the length of the canal covered in 60 minutes will be also 10 kilometer. So in 1 minute will be 10 by 60 rather. So the length of canal covered in 30 minutes, because that's what the question is asking you, will be equal to 5 kilometer, which is 5000 meters. So now we have got all into meters. So we have found out the length of the canal as 5000 meters. Now we know that the canal is cuboidal in shape. So the volume of canal you can find out, length into breadth into height. So which is 45,000 meter cube. Now the volume of water in the canal is equal to the volume of area irrigated. So what will be the area irrigated? Whatever the area is getting irrigated into height. That means the water is getting spread out in that particular area, and it needs to spread out for a height of 8 centimeter. So since you know the volume of the canal, so the area which is going to be irrigated, so whatever is the area into 8 centimeter, so you get the area irrigated as 45,000 by 8 by 100, because once again it is in centimeters, so you need to convert it into meters. So you will get the answer as 5,62,500 meters square. And remember, when the number is big, the unit cannot be small. So we need to convert this into a bigger unit, so which is going to be 56.25 hectares. This is the last question. A farmer connects a pipe of internal diameter 20 centimeter from a canal into a cylindrical tank in her field, which is 10 meter in diameter and 2 meter deep. If water flows through the pipe at the rate of 3 km per hour, in how much time will the tank be filled? Now understand the question. This farmer connects a pipe of internal diameter 20 centimeter from a canal into a cylindrical tank in her field. Now this farmer has connected in the cylindrical tank along with a pipe which is cylindrical in shape, and the diameter of the pipe has been given. Now the tank which is there, it is 3 meter in diameter and 2 meter deep. So you need to find out how much time the water flows through the pipe at the rate of 3 kilometers per hour. Now look at the solution. This is the measurement of the pipe. It is given 0.2 is the diameter and the speed is given 50 meters per minute. So the radius will be equal to 0.1 meter. So area of this cross section will be 0.01 pi. So speed of water is 3 km per hour. So convert this into meters per minute because all the other units are in meters. So we convert into meters per minute. So we get 50 meters per minute. So volume of water that flows in 1 minute is equal to 50 into 0.01 pi, which is equal to 0.5 pi meter cube. So volume of water that flows in whatever t minutes you can write down from the pipe is time into 0.5 pi meter cube, and radius of the circular end of the cylindrical tank is 10 by 2, 5 meter. Now we come to the cylindrical tank. This is the tank which is there and the pipe is filling this tank. Now the radius of this tank is 5 meter and the depth is given 2 meter. So volume of water filled in tank in t minutes is equal to volume of water flowing in the pipe in t minutes. So volume of water that flows in t minutes from the pipe will be equal to volume of water in the tank. So using this formula, so t into 0.5 pi, which we have already calculated, will be equal to pi into r2 square into h square, which is basically the volume of the water in the tank. Calculating this, we get time equals to 100 minutes. Thank you. May you have an amazing day.